about significant figures. What is significant figures? Well, one of the best examples is how I want to find the mass of a penny. I mean, why not? Who wants to know the mass of the penny? Well, I do. So I went and I found 3 different balances at Roanoke College. Here's a balance like we use in class, and I found that the mass of the penny was 2.48 grams. I thought, okay, that's good. So I went and found another balance, and I found that the mass of the penny on that balance was 2.499 grams. Thought, okay. Then I found a really fancy balance like the one over here, where it has like a door and you have to open the door, you put your sample in, and it gives you tons and tons of decimal places. The one I used happened to be a 4 decimal place balance. And I found the mass of the penny was 2.5010 grams. So being the good chemist that I am, to report the average of the mass of the penny, I averaged them together, and I got this huge long number with a repeating decimal of 2.4933333. So in my lab notebook, that's what I should record and report as the average mass of a penny. I should definitely use all of these threes. Well, in actuality, you're not allowed to do that. If you take a look at my measurements, we were limited by the precision of the balance that only allowed us to have 2 decimal places. So for example, my balance over here that only had 2 decimal places is my least precise balance. Therefore, my average can be no more precise than my least precise instrument. And so because my least precise instrument had 2 decimal places, I'm only allowed to have 2 decimal places. So I'm only limited to reporting the average mass of the penny is 2.49 grams. So why for all the rules? Well, we're going to explain why in this particular lesson. So let's talk about some new examples. Significant figures is how we are going to keep track of the precision in a measurement. So for example, when I talk about the amount of precision in an instrument, I'm going to be referring to that as significant figures. They're all also known as significant digits, are all of the digits that can be known with certainty in a measurement. So for example, the precision of the instrument that I was using allowed me to know that, plus an estimated last digit. We'll talk about that some more as we learn how to read a meniscus, for example, on a graduated cylinder. Significant figures provide a system to keep track of the limits of the original measurement. So what we're going to do in this lesson is talk about this system or a set of rules that will allow us to keep track of our measurements and the amount of precision in them. So what we're going to talk about next are these rules or that system that allows us to keep track of the amount of precision in a measurement. So, for example, the first rule is that all digits are significant. Now, one thing that's kind of a misconception is what exactly is a digit? A digit is any number 1 through 9. So you can see how that excludes a 0. So what I'm going to do is I'm going to talk about this measurement, 45 kilograms. I'm going to use check marks to help me apply rule number 1. I'm going to put a check mark above any number that is a digit, number 1 through 9. So the 4 is a digit, the 5 is a digit. Oh, I've gotten to the end of my measurement. Well, that was easy. So how many significant figures did I have? I had 2 significant figures. Let's move on to the second rule where it gets a little bit more complex. In the second rule, I'm going to still apply the first rule, but in addition to that, I'm going to say that any 0, so we're going to start talking about this idea of something that's not a digit, a 0, is going to be significant if it's between significant figures. So that would be something I call the sandwich rule. Let me show you how that applies. For example, let's take a look at this measurement, 307 centimeters. I'm going to apply rule number 1, which is all digits are significant. So I'm going to put a check mark above any number that's a digit, 1 through 9. So the 3 is a digit and the 7 is a digit. Now, if you take a look at this 0, this rule applies. Any 0 that is between significant figures is significant. So this 0 is between these check marks. So I can apply the sandwich rule, and I can put a check mark above that 0, saying that it is significant. So there are 3 significant figures. Now, often when students hear the word significant, they think that it means important, but that is not the case. When I say significant, I do not mean important. I mean that that value is actually part of the measurement of what the instrument was that allowed me to collect the measurement. So significant does not mean important. Instead, it means measured. So I'm going to go to my next measurement, 9,004 meters. So I'm going to start with rule number 1, and I'm going to put a check mark above all digits. So that would be the 9 and the 4. Next, I'm going to put a check mark above all zeros that are in a sandwich. This is a pretty big sandwich, but these zeros are between significant figures, so therefore they are significant. And again, by significant, I mean measured. And so I'm going to go ahead and put check marks above those zeros as well. They are measured. And so I will say I have 4 significant figures in this measurement. It does get a little more complicated in our next example. In the next example, we still apply the previous 2 rules, but we have a third rule. And this one gets a little tricky. Any zero that comes after, and by after we mean to the right-hand side, a digit and a decimal. So those are 2 things that must be present. It must be after a digit and a decimal, then it is significant. So let's take a look at some problems where that will be the case. So the first one, 93.0 grams. I'm going to start with rule 1, where I put a check mark above all digits. So the 9 and the 3 are digits, numbers 1 through 9. They are significant or measured. Rule number 2, we have to look for zeros in a sandwich or between significant figures. This 0, it is not in a sandwich. Next, I'm going to look for zeros that are coming after, meaning to the right-hand side of a digit and a decimal. This 0, whoops, didn't mean to make that straight mark. This 0 is to the right-hand side of a decimal, and it is to the right-hand side of a digit. And by anywhere to the right-hand side is what I mean by that. So therefore, it is also significant. And there are 3 significant figures. In the next measurement, I'm going to start by putting a check mark above all digits. And I'm going to look for any 0 that is in a sandwich, which is the second rule, and I currently do not see any. I can always go back and revisit that rule or any of these rules in any order that I might want to. Next, I'm going to look at rule number 3 for zeros that come after a digit and a decimal. So when I do that, I'm going to notice that these 2 zeros here, they come after, meaning to the right-hand side of this decimal, and they come to the right-hand side of the digit, the 4. Some students might say, well, does it have to be directly after? No, just anywhere to the right-hand side, and these do. So therefore, they are significant, so I'm going to put check marks above them, and I'm going to say that I have 3 significant figures. Or remember, significant does not mean important, it means measured, part of the precision of the instrument that I use to make this measurement. Let's go ahead and look at the next example. In the next example, it's a little trickier. I'm going to start by putting check marks above all digits. I just have the 9. Next, I'm going to look for zeros in a sandwich. I do not yet have any. I can always go back if I need to. The third rule, I'm going to look for zeros that come after a digit and a decimal. So in this situation, I'm going to take a look at these zeros here. Notice how this one does not come after a digit or a decimal. It's not significant. These 2 here, they do come to the right-hand side of a decimal, but they do not come to the right-hand side of a digit, so they are not significant. If I look at this last 0, it does come to the right-hand side of this digit, and it comes to the right-hand side of a decimal. So therefore, it is significant, and I will say that I have 2 significant figures. So in this particular measurement, I'm not saying that these zeros are not important. I'm saying they are not part of the precision of the instrument that allowed me to make this measurement. Only 2 are known with certainty. All right, next, we're going to go to 700 kilometers. I'm going to start by putting a check mark above all digits, which is rule 1. Rule number 2 is look for zeros in a sandwich or between significant figures. I don't see any. The third rule, I'm going to look for zeros that come after a digit and a decimal. These 2 zeros here, although they come to the right-hand side of this digit, they are not to the right-hand side of a decimal. Therefore, they are not significant, meaning not that they are not important, but they're not part of the precision of the instrument that allowed me to make them. They're not known with certainty. Therefore, I only have 1 significant figure. In the last measurement, we're going to go ahead and start putting check marks above all digits, and I'm going to look for zeros that come in a sandwich, meaning they are between significant figures. And at the current moment, I don't have any. Next, I'm going to look at rule 3, any 0 that comes after a digit and a decimal. This 0, right here and right here, they are to the right-hand side of a digit, but they are not to the right-hand side of this decimal. This one is. This 0 is to the right-hand side of a digit, and it's to the right-hand side of a decimal. Anywhere to the right-hand side. Now I'm going to have to go and revisit rule number 2, the sandwich rule. So you don't have to do these in order. Notice how now these zeros are in a sandwich, or they are between significant figures. Therefore, I have 4 significant figures.